What does a Kentucky coal mine have to do with landing on the moon? More than you would ever guess. There is a machine sitting at Cape Canaveral that weighs about 6.5 million pounds. That is as much as 1,000 pickup trucks, and it crawls along slower than you walk. It carried the Saturn V to the launch pad. Then it carried every space shuttle. And today, it carries the rocket built to take Americans back to the moon. But it did not come out of a NASA lab. It came out of an idea a NASA engineer had standing on his father's farm near Paradise, Kentucky, watching a coal shovel the size of a football field tear into the ground. Ohio shovel makers built it, not a rocket company. 2 of them came off that line. One still walks. The other has sat dead still for years, waiting on a customer that never came. We went and checked on both. Picture the job for a second. You are sitting in a cab on a steel deck about the size of a baseball infield. Above you, lying flat on its back, is a rocket worth billions of dollars. Your job is to move it 4 miles to the launch pad without tipping it, without cracking it, without losing it. And the steering wheel in your hands is roughly the size of a dinner plate. You do not turn it and go. You turn it and wait, because the steering takes 30 or 40 seconds to actually bite. So the drivers start cranking that wheel a full 50 yards before the curve even arrives. One of the men who does this for a living put it plainly. It is nothing like a car, where you turn and the thing turns. You have to think half a minute ahead the entire way. And sometimes the machine just stops. Not for a warning light, for an alligator. One driver described pulling up on a 12-foot gator lying flat under one of the tracks. And the rule out there is simple. Nothing moves until a wildlife officer comes and drags it out. A 6.5 million pound machine hauling the most expensive cargo in the country, sitting still, waiting on a reptile to clear the road. Here is what they are actually moving. Loaded up with the rocket and the launch tower it stands on, this machine can carry 18 million pounds. In plain terms, that is the weight of more than 20 fully loaded jumbo jets balanced on one platform, rolling down a gravel road. It walks on 8 tracks, and every track is built from 57 steel shoes. That is 456 shoes in all, and each one weighs a full ton. So before you add the rocket, before you add a drop of fuel, this machine is already dragging more than 400 tons of its own feet across the ground. And it does all of it at less than 1 mile an hour. With the new moon rocket on its back, it slows to about 0.8 miles per hour. There are people who walk their dog faster than this machine moves the future of American spaceflight. But every inch of that slow is on purpose. And in a minute, you will see exactly why. If you want to understand how a coal mining machine ended up doing the most delicate job in the entire space program, stay with us, because the answer is genuinely strange. Like and subscribe. It tells us these stories are worth telling. So how did this thing come to exist? Back in the early 1960s, NASA had a problem nobody had ever solved. They were building a rocket, the Saturn V, that would stand taller than a 30-story building. You could not just wheel something like that out to the pad. You had to stand it up, assemble it, and move it upright and fully built for miles, without bending it. The engineers chewed on rail systems and canal systems, and came up empty. And then one of them went home to visit his father's farm down in Paradise, Kentucky. Right next door, a coal company was stripping the land with a machine called the Big Hog. It was a Bucyrus-Erie shovel, and it was a monster, with a platform as big as a football field, tracks 8 feet high, and a diesel engine sitting inside each track. He was not looking at a coal shovel anymore. He was looking at the undercarriage of a moon rocket transporter. And some of you already know that exact machine from this channel. The Big Hog. The one later buried in a Kentucky mine. The very machine that handed NASA the idea. Now the twist the textbooks skip. The shovel that sparked it was a Bucyrus-Erie. But when NASA put the job out for bids, Bucyrus-Erie lost. The contract went to their oldest rival, the Marion Power Shovel Company, out of Marion, Ohio. These were the people who, decades before, built the steam shovels that dug the Panama Canal. They had spent a century building the biggest digging machines on Earth. And now they were going to build something nobody had ever built, for $14 million apiece. The pieces were forged up in Ohio and shipped down to Florida, where the two machines were bolted together right on site, because nothing this size could be moved in one piece. By 1965, the first one rolled under its own power. By 1967, it was hauling the first Saturn V out to the pad. And the trick they pulled off still does not make sense when you say it out loud. The road to the launch pad is not flat. The final stretch climbs a ramp at a 5% grade, and if you tilt a 30-story rocket even slightly, you are in serious trouble. So the machine carries a hydraulic leveling system, and as it climbs that ramp, it holds the very top of that rocket level to within about the width of a basketball. A tower of explosives, climbing a hill, kept dead level by a machine designed before color television was common. Underneath it, two enormous diesel engines, the same kind that pull freight locomotives, make the power. They do not drive the tracks directly. They spin generators, and that electricity runs the motors on the wheels. Even the road is part of the design. The crawlerway is packed 7 feet deep with smooth river rock hauled in from Alabama and Tennessee, chosen because it has low friction and will not throw sparks near a fueled rocket. And as the machine rolls over those stones, it slowly grinds them into sand. It eats its own road, a little more, every single trip. This is the kind of engineering that disappears if nobody talks about it. Like and subscribe if you want more machines like this one. But a machine this big, doing a job this precise, was always going to fight back. And it did, right from the start. On one of its very first test runs, crews found broken metal scattered on the ground behind it. Bearings deep in the drive system had torn themselves apart while it was moving. The whole design had to be pulled back and reworked before anyone trusted it under a rocket. That was only the warm-up. Jump ahead to the year 2000. The Space Shuttle Endeavour was riding out to the launch pad for a mission to the International Space Station. Partway there, one of those 1-ton steel shoes cracked. And with a broken foot, you cannot just limp the rest of the way. The entire machine had to stop, reverse, and carry the orbiter all the way back down to level ground so crews could fix it. A space shuttle turned around and sent home because the machine under it broke a toe. Then came the close call that almost nobody hears about. 2 years later, engineers opened the machine up for a deep inspection. Inside the hydraulic cylinders that hold the entire load level, doing the single most important job on the whole machine, they found cracked bearings. Not one or two. Nearly half the ones they checked had cracked, and there were almost no spare parts left anywhere on Earth to replace them. If one of those had let go while a loaded shuttle was climbing that ramp, the engineers admitted it would have been extremely hard to fix, and it could have grounded the program. A machine from the 1960s, quietly carrying that kind of risk under every rocket it moved. So you would think NASA would have replaced it by now. They looked into it, and every time, the answer came back the same. It was cheaper to rebuild these old giants than to start from scratch. So instead of scrapping them, They made one of them stronger. Between 2014 and 2016, crews tore into the machine known as the second crawler and rebuilt it for the new moon rocket. New bearings, new generators, a new leveling system, heavier steel almost everywhere. They raised what it could carry from 12 million pounds to 18 million. And in doing that, they made the machine itself heavier. So heavy that in March of 2023, Guinness World Records handed NASA a certificate naming it the heaviest self-powered vehicle on the planet. That is the careful version of the title, and we are going to be straight with you about it. When these machines were built, they were the largest self-powered land vehicles in the world. A Chinese crane passed them on sheer size back in 2013. The giant German digging machines weigh more, but those run on power piped in from the grid. By the measure that matters here, weight that moves under its own power, the crawler still holds the record, 60 years on. But notice we keep saying the machine, because there were two of them, and it is the second crawler that got the full rebuild. The first one has a very different story. Back in 2019, NASA struck a deal. A company called Northrop Grumman was building a brand new rocket called Omega, and the first crawler was going to be its ride to the pad. The old Apollo workhorse was getting a second life, hauling commercial rockets into a new era. And then, in September of 2020, Omega was cancelled. Northrop Grumman lost the big military launch contract to its competitors, and just like that, the rocket the first crawler was waiting for stopped existing. So we went looking for what that machine is doing today, and the honest answer is, we could not find one. NASA's own current page on the crawlers is all about its twin carrying Artemis to the moon, and it barely mentions the first machine at all. There was no mission for it, no customer, and no clear future anywhere on the record. One of the two greatest land machines America ever built is sitting still, listed on a register of historic places, waiting on a phone call that may never come. Think about what that machine has seen. It carried the rockets that put men on the moon. It carried the space shuttles, every last one, for 30 years. It is older than the moon landing itself, and it is still rolling, while faster, newer machines came and went all around it. They built it out of a coal shovel for $14 million in a town in Ohio most people could not find on a map. And 6 decades later, NASA still cannot build anything better to do the job. If you ever worked at Kennedy, or you stood at a fence and watched one of these crawl a rocket out to the pad, tell us about it down in the comments. We read them. Like and subscribe, and we will keep digging up the machines that history almost forgot.